Okay, so video, hopefully it is starting, and it is. Let me get this done. So the first, find the equation for the proportional relationship represented in the table. So the constant proportionality, you can take any of these points, whether it's 2 and 12, 3 and 18, 4 and 24, 5 and 30, and find the constant proportionality. So the constant proportionality is k equals y over x. So I'm just going to randomly pick this line, so 0.318. Remember that this is the x and this is the y. So if I did k equals y over x, I would get 18 over 3, and k would be 6. So my constant proportionality is 6. So from that, remember that I can quickly find the equation. So I know what k is, so it's just simply substituting k, replacing k with 6, and I get y equals 6x. So there is my equation, the equation of my line. Now, I want to check if, now imagine if I were to continue this table, 6, 7, 8, 9, right? They would each would have a corresponding y value. So with 9, so with 6, so again, everybody can see it's a times 6, times 6, times 6. So with 6, I would have 36. With 7, I would have 42. With 8, I would have 48. And with 9, I would have 54. So the 0.963 is definitely not on this line, right? So this would be a no. So one way would be to continue the table and see what I would get with 9. So it's saying that with 9 you should get 63, but in reality with 9 I get 54. So another way of checking, and you're using the equation. So y equals 6x is my equation. So let's use the 0.9 and 63, see if it works. So this is my x and this is my y. So if I replace my y with 63, I get 6 times 9, and you can tell that 6 times 9 is 54, which is not equal to 63, so it's not on the line. So basically that means that if I were to plot these points, right, 2 and 12, 3 and 18, 4 and 24, 5 and 30, 6 and 36, 7 and 42, and then let me just erase this, 7 and 42, 8 and 48, 9 and 54, right? That'd be a straight line. I get this starting at 0, starting at 0. Right? All those points are on top of the line, right? But the 0.963, 9 comma 63, would not be on top of this line. 9.63 might be a point that it's over here. As you can clearly tell, it's not on the line itself. Okay, so that's another way of checking. Sam made 124 cookies. Oh, I forgot to bring a calculator, so it's okay. 124 cookies. How many cookies can she make with 1 pound of chocolate? So 124 cookies were made with these many chocolates, and instead of using 2 and 3/5, I'm going to write 13 over 5. Okay, pounds of chocolate. So with 1 pound, so this is pounds of chocolate, right? 2 and 3/5. So how many cookies can I make with 1 pound of chocolate? So we can obviously find the unit rate and multiply this times 5 over 13, multiply this times 5 over 13. So this all simplifies to 1. That's how I get my 1 pound. And on top I can multiply 124, so it's going to be 124 times 5, and then divided by that number. So 124 times 5 divided by 13. If you have a calculator, please go ahead and use so. 124 times 5 equals divided by 13. You're going to get 47. I don't have a calculator. I can't leave it as a fraction, but you're going to get 47 and 69.69 cookies. Okay, so if you have a calculator that uses fractions, I'll just do it out here. 124 times 5 over 13. So 124 times 5 is 6. 124 times, I hate my calculator. 124 times 5 equals, it's 620 over 13, right? So if I change that to a mixed number, I'm going to get, let's see, 620 divided by 13. Let me just do that on the side. 620 divided by 13. 13 times 4. Investment calculator. 13 times 4 is 52. So that'd be 100 left over, right? And then 13 times 7, yeah, it's going to be 91. 13 times 7 is 91. I have 9 left over. So, or you can, if you want, write a fraction, it's 14, 9 over 13 cookies. So you can make 47 cookies and almost a little bit more than half of the next cookie. So either of these are completely fine. Tony ran 9 1/5 miles in 2.5 hours, 2 1/3 hours. What was his distance traveled per minute? Ooh. So let's change this. I mean, there's so many ways you can do this, and I'm just gonna do it. Let's say it's 9 1/5 miles, right? And he ran that in 2 1/3 hours. So I'm going to change that to hours first. So let me do that. So what did he run in 1 hour? Obviously, it's going to be a little less. So 2 1/3, 2 1/3 changes to 7 over 3. So I'm going to replace the 2 1/3 and write it as a mixed number, 7 over 3. Right? And I'm going to multiply that by the reciprocal. I'm going to get 3 over 7 here and multiply by 3 over 7 over here. So at the bottom, I get 1 hour. And on top, 9 1/5, which is 9 times 5 is 45, 46 over 5, right? So this can be rewritten as this. Multiply by 3 over 7, and I'm going to get some ridiculous number. 46 times 3 equals 138 on top and 35 at the bottom. Don't worry about that for now. So 138 over 35 miles in 1 hour. Now, the question says how much did he travel per minute. So now what I can do is change the 1 hour. So let me write that here. 138 over 35 miles. He runs all that in 1 hour or 60 minutes, which is the same thing as 1 hour. Now I can now take that and find out the unit rate per minute. So I can do that. I can divide by 60 here and divide by 60 here, right? So I can, if I were to do that, I'm going to get 138 over, what is that, 35? 35 times 60, 2,100. And I can definitely simplify this over miles. Okay, but I'm going to leave it like this for now. Okay. Yeah, that's it. 4. Which of these 4 graphs represent a proportional relationship? I'll make this a little bigger. So definitely not this one, because it does start in the origin, but it's not a straight line, so that's out of the picture. B starts at the origin and straight line, good. And C starts at the origin, straight line, so that's also proportional. But D does not start at the origin, so D is gone. So explain how you decided whether or not D shows a proportional relationship. Well, for D, I noticed that it doesn't start at the origin. It starts at 1 here on the y-axis, so definitely not a proportional relationship. So that's all gone. So now I'm left with B and C. So for B and C, you're asked to find K, and you're asked to find the equation. Okay, so let's do that. So let's take a look at B. So a look at B, and I'm going to make it bigger, and see if you can find a point that you can actually measure. And I think this is right on that corner. So I could have chosen that one. And it looks like that's the only one, or maybe this one too. Okay, so this first point is 0. So if I'm put a 0 here, it's 1, 2, 3. It's 3 to the right, 3 on the x-axis, and 1, 2, and 1 on the y-axis. So the point 3, 1. So you can use that one, or you can use this one. This one would be 6 and 2. You can use any of those 2 points to find K. So K is y over x. And this one is obvious because you already see the unit rate. So I'm just going to use 3 over 1. So actually, it's not obvious. It's 1. The y is 1. The x is 3. So K equals 1/3. So that's my constant proportionality. If I want to write the equation, y equals kx. I'm going to replace the k with 1/3 x. So that's the equation for this guy right here. C, for letter C, same thing. Let me pick a value that I can, this one works. I think this one works. That's, let's see, 1, 2, 3, 4. So that's 4, comma, and 1, 2, 3, 4, 5. That's point, comma, 4, comma, 5. So that's my x, and that's my y. So let's find our constant proportionality. K equals 4/5, or k equals 5/4, actually. Y, right? It's k equals y/x. So my constant proportionality is 5/4. If you, this one actually divides nicely. You can write it as a what do you call, as a decimal, because the previous one ended up being like a repeating decimal. So this one actually, you can leave it like that, or you can write it as 1.25. So either or, doesn't matter. And on your equation, you can write y equals kx, or y equals 5/4x, or y equals 1.25x. Either or would have been just fine. So just let me separate this. Taylor spent $43.92 on 8 reams of paper. Who's your x and who's your y? So let me write as a fraction here. $43.92 and 8 reams of paper. So this is my y and this is my x. So imagine this was a graph. This would be my dollars. This would be my reams of paper. So 0, 1, 2, 3, 4, 5, 6, 7, 8. 10, 20, 30, 40. And I'm making this up, by the way, because obviously. So, and this would be 43.92. So this point right here is 8 reams of paper. In 8 reams of paper, I'm going to spend $43.92. Okay. So I'm writing this information here that was given to us in the sentence as a ratio in the form of a fraction, or I put it on the graph. And then I'm asked to come up with an equation. Well, to write an equation, I need to find what k is, right? So k is y/x, and we can clearly see that this is my y and this is my x. So I'm going to put k equals 43.92 divided by 8, and k is going to be, I have no idea, 43.92 divided by 8 is going to give me 5.49. That means that each ream of paper, so my unit rate is $5.49 for 1 ream of paper. From this, I can write my equation, y equals kx, or y equals 5.49x. Okay, where y represents the total and x represents however many reams of paper I want to buy. Okay. So next one, number 6, I kind of briefly mentioned in class. So I want you to think what this means. Any shape, as long as it's equilateral. So it could be a square, a triangle, pentagon, or something that has where all the sides measure. So let's stick to the triangle here. So this question says, the relationship between the length of a triangle, equilateral triangle, and the perimeter can be represented on a coordinate plane with a straight line. So this is what they mean. So, and let me first, so this is the side. Let me create a table here so I think it might be easier to understand. Side, the length of the side, and this is the perimeter. Remember, the perimeter is all the sides added together, right? So think about it for a second. I have a triangle where all the sides measure the same. This is 1 inch, this is 1 inch, and this is 1 inch. So when the side of the triangle is 1 inch, right, one of the sides measure 1 inch. What is the perimeter? Well, if I add all 3, I get 3. When the side of an equilateral triangle, when all the sides, what happens when there are 2? So when the side of a triangle is 2, what would be the perimeter? Well, it would be 6, right? 2 plus 2 is 4, plus 2 is 6. What happens when the sides are 3? So I'm going to change that to 3. The perimeter, the total, would be 3 plus 3 plus 3, which is 9. what happens when it's 4. So you can tell now that's a relationship, right? It's times 3, times 3, times 3. So if every side was 4, you would just do 4 times 3 and you get 12. So this is what I am working with. Now, if I were to graph this, I would put side over here and P for perimeter here. So I'm just going to make 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's my 0. Here I'm going to go by 3. 3, 6, 9, 12, 15. So when the side is 1, my perimeter is 3. When the side is 2, the perimeter is 6, and so forth, and so forth. And you can clearly tell that it's going to be a straight line, right? So what they're asking is, I want you to take a look at these following points, 1 and 4, 4 and 12, 10 and 30. Would these points be on the line, or would they be like outside the line? So you got two choices. They're either on the line or outside the line. So let's look at 1 and 4. When this says that when the side of the triangle is 1, the perimeter is 4. Would that be on the line? No, because and I'll change colors. 1 and 4 would be a little bit above, somewhere over there. So 1 and 4 is not on the line. Besides, the relationship is not the same, right? How about 4 and 12? When the side is 4, will the perimeter be 12? Yes, look, it's right on top of the line. And finally, 1030. Well, 1030 is somewhere off my what do you call my chart. But when one side of the triangle is 10, will the perimeter be 30? And you can clearly tell that there is a times 3 relationship here. So you know it's going to be on the line. So find the equation. So I want you to take one of these points. Okay, take one of these points. And I don't know, let's just pick 10 and 30. So k equals y over x, k equals 30 over 10, k equals 3. So the equation of my line would be y equals 3x. And that makes sense, right? It's 3 times whatever the side is. So that's that. Number 7, Kim writes blah, blah, blah. How many can she write in 4 hours, per hour, and how many can she type in what? How many can she type in 6.5 hours? Yikes. So let's do this. So let's write it as, I like to write it like this, words in 2/7 of an hour. So you want to find the rate per hour, right? So in 1 hour, how much does she write? So let's multiply this by 7 over 2. And on top by 7 over 2. Bottom one will all cancel out and simplify to 1. On the top, we're going to multiply 1,440 times 7 and then divide it by 2. I'll divide that by 2, which means that she writes 5,040 words in 1 hour. So now we want to find out how much she types in 6.5 hours. 6.5, you can write 6.5 hours. So times 6.5, and on top, times 6.5. That one is simple enough. 32,760 words in 6 hours and a half. Okay, so there are 2 steps here that you needed to do. 8. Sam can make 12 paper airplanes in 5 minutes. Johnny can make 25 airplanes in 12 minutes. Who makes more per hour? Okay, so let's do Sam first. So Sam makes 12. I'm just going to write P, paper airplanes, in 5 minutes. 1 hour is the same thing as 60 minutes, right? So can you find a relationship? Yeah, times 12. So it'd be times 12, which is 144 paper planes in 60 minutes or 1 hour. So that's how much Sam makes. Johnny, let's see, Johnny. He makes 25 paper airplanes in 12 minutes. I should have said 12 minutes. Okay, so again, an hour is 60 minutes, so this would be a times 5 relationship, and times 5. And Johnny makes 25 times 5 is 125 paper airplanes in 1 minute. And who makes more? Well, you can clearly tell that in 1 hour, Sam makes 144, which is greater than 125. Okay, by 19 airplanes. Okay. Number 9, so here we have a graph. So you know it's as a constant, it's what he calls proportional, right? And it says find the constant proportionality and the equation of the line. So now, to find a constant proportionality, you would find where 1 is, right? 1, and you would match it with here. But I can't really tell what that is because I'm not going to guess on the value. So what you can do is pick a value that you actually can see. So this would have been okay. Let me change colors. This would have been okay because that I know, this I know, this I know, this I know, this one, and that one also. So let's stick to the point that they actually gave us, 12 games and 48 points, right? 12 games and 48 points. So we can use that point, but you didn't have to. You could have picked any other point that you can actually tell the value. So 1248. I bought 12 games, therefore I got 48 points. This is my X, this is my Y. So it says find a constant proportionality. That's okay. So it's 48 divided by 12. So my K is 4. My unit rate, okay, I didn't ask, but my unit rate is going to be 4 over 1, or 4, in this game, 4 points for every game that I buy. That's so, and then we can find our equation of line, which is y equals kx. We just found that k was 4, so we get y equals 4x. That makes sense. When I buy one game, I get 4 points. When I buy 2 games, it's 4 times 2, which is 8, and so on. And so on. 10. The cost of different sized boxes of cereal are displayed. Find the better deal. Okay, so let's take the first one. Let's call this A, B, C, D. So for A, it's 2.64 over 12 ounces. 12 ounces, and we want to find a better deal. So let me change this. Okay, so I'll find an equivalent ratio, but with 1 ounce. So it's divided by 12, divided by 12. 2.64 divided by 12. It's going to give me that it's 0.22 cents per ounce. Cereal B, it's $3.80 divided by 20 ounces. And again, I'm going to divide this case, simplify this to 1 ounce. So it's going to be divided by 20. 3.80 divided by 20. It's going to give me 19 cents per ounce. C, it's $5.44 for 32 ounces. So if we simplify that to 1 ounce, it's just divided by 32. 5.44 divided by 32 equals 17 cents an ounce. And the last one, the big package, the biggest one, which is 48 ounces. Usually the bigger packages are the cheaper one. But who wants to eat all that cereal? 48 ounces. Again, we want to simplify this to 1 ounce. So it's just 8.64 divided by 48. That's going to give us 18 cents per ounce. So 18 cents per ounce. Put that there. So the cheapest one is actually C. Okay, the 32. That gives you the better deal. Okay. So here, they're simply asking you if the equation that's already given to you, C equals $4, C equals 4W, is the equation for this graph. Okay, so what we can do is find a point. Okay, this is, I think this says, let me write 1, 2, this looks like 3 and 4. So look, let's look for points. So that point seems like point 1 and 4, right? 1 and 4. This one, I can't, no, it is 2 and 8. This one is 3 and 12. And it's so forth, so forth. So I can pick any of those points to find K. But we already know that this, because it's compared to 1 pound, I already know that K is 4, right? Just by looking at that. So I'm just going to do it anyway. So it's y over x. So I'm going to, let's use a 0.14. It'll be 4 over 1. And you can see that K equals 4. So you can either do it, substitute the values, or just know that this point right here was our unit rate. Therefore, I can find k. And if I know k, I can now come up with the equation. The equation would be y equals kx and or y equals 4x. And this is the same thing as this, except that they use different letters for x. So remember, this represents the x-axis and this is the y-axis. For x, they use the letter w, and for y, they use the letter c representing the total. That's all that was. Okay. So that was pretty easy. 12, find k in the equation of the line. We just got oh, this one. Okay, so this one, a lot of you got confused, but 12 is talking about this graph. So the hiking distance. So we got time, x, which is x, and the distance, which is y, and we want to find the k in the equation of the line. So pick any of these points. And again, they highlighted a few for you, or they circled a few for you. So let's see. This is 10, 12. This one is 15, 18. And this one is 5, 246. So any of those that you want to use to find k is fine. So it doesn't really matter. I'm going to pick this one. The lower the number, the less work I have to do because I don't have to simplify. So if I use the 0.56, this is k and this is x and this is y. So k equals y over x or k equals y over x. K would be 6 over 5, right? And you can leave this as a mixed number, or if you write that as k equals 1 1/5, you can also write this as k equals 1.2. Doesn't matter which one they use. I wouldn't use this one though. I would use either this one or this one in my equation. So now the equation of my line is going to be y equals kx or y equals 1.2x. That's fine. Or y equals 6 over 5x. We can use this one or this one, and it would have been just fine. 13. Explain whether the graph has a proportional relationship or not. Explain what 0, 5 means in the context of this scenario. So it's definitely not proportional. Why? Because it doesn't start at 0, 0. It doesn't. So, so 0 games, total cost. So explain what 0.5 means. So how is it that when he buys 0 games, he's still paying $5? That's what you had to explain here. Because two games, he's paying, like this is 2 and 15. So with 2 games, he paid 15. With 3, he paid 20. With 4, he paid 25. So, but how is it that at 0 games, he's still paying $5? What's the explanation for that? Well, the one explanation could be, well, he's buying 0 games, but he might be buying something else, like a controller or a membership fee or a hat or a cup or whatever it is that he's buying. That would explain that even though he's buying 0 games, he's still paying $5. So there must be something else besides games that he's buying. Okay, and that explains that. Okay. 14, find the coordinate for k, the constant proportionality and the equation. So where is the constant of proportionality here? The constant proportionality here is here. Where 1, right? 1. This is k. The unit rate. And the unit rate is always when we compare it to 1, right? When x equals 1, that is the unit rate. So we take a look at that point. That point is 1, 2. Just to prove it to you, k equals yx. And if we substitute, the y is 2, so let me just write the point here. This is x and this is y, be 2 over 1, and 2 over 1 is the same thing as 2, and that's a constant proportionality. And if I substitute y equals kx, I'm going to get that y equals 2x, and that's the equation of my y. Okay, so right away from the graph, I could tell you right away what the constant proportionality is whatever the y value is when x equals 1. So when x equals 1, the y value is 2. So this number over here, that's k. And if I know what k is, I know what the equation of the line is. 15, 14, 15, last one, yay. So we have Determine the difference in miles walked after 5 hours. Okay. So 2 people are walking, person A, person B. So let's see how we can. Let's take a look at person A. Person A, let's find out his how fast he walks or whatever. Let's use a point that we can use. No, but yes, this point we can use. So our graph is going by 0.5 every 2. 0.5, 1, 1.5, 2. This guy over here is 2.5. So when x is 2.5, my y value is 0. This is 1. What's between $1 and $1.50? $1.25. So we can write 125. So based on this point, I can find k, and I can find the equation of the line. So k is 1.25 divided by 2.5. 1.25 divided by 2.5 is going to give me 0.5. So k is 0.5, and I can make my equation, which is y equals 0.5 times x. So keep that in mind for a second. Let's look at person B. Person B, we can use, person B is even easier. So when x is 1, when he runs for 1 hour, right here, 1 hour, how far did he go? He go 125. So he went, when x is 1, he went 1.25 miles. So we already have the unit rate, which is great. So again, I'm just going to do it because is y over x, 1.25 over x, which is 1, or k is just 1.25, which we already knew. So the equation of this line is going to be y equals 1.25x, which means that this guy here, so let me write the unit rate here. The unit rate here is 1.25 miles in 1 hour. That's how far he traveled. And this person over here travels, from here I'm going to take the unit rate, 0.5 miles in 1 hour. Now obviously, person B is the faster person. He's running a little bit more. And the question is saying, what happens after 5 hours? So after 5 hours, we can use the equation, and that's what we're going to do. So y, the total, 0.5 times 5. After 5 hours, how far will he go? And 0.5 times 5 is just 2.5. So in 5 hours, he's going to walk 2.5 miles. Here, y equals 1, let me change color, sorry, 1.5, y equals 1.525 times 5, right? Because that's, and then you're going to get y equals 1.25 times 5, and that's going to give that he walks or runs 6.25 miles in 5 hours. So definitely he walks much more. Okay, so very, very straightforward. I don't think there's anything too difficult here. Okay.